All right, here's example 2. This is on page 60. Example 2 has to do, it's a problem that has to do with finding the instantaneous rate of change, or something that we call the instantaneous speed, um, as opposed to an average rate of change, which had to do with finding the slope of 2 points. So with this kind of problem, you're looking at the slope at one particular point. In this case, your t, or the x value, being 2. So what is your slope at that point? So how do we do that? Okay, you could approximate what this value is by choosing another t value that's in the proximity of 2. For example, you could choose t to be 2.01, you could choose t to be 1.99 or 1.999, 1.999, or t to be 2.001. So at least that gives you an approximate value for that instantaneous speed. So if you let t to be 2.01, let's take a look at what f of 2 was. Let's take a look at what f of 2.01 was. When f is 2, we found the f of 2 to be 64. When f is 2.01, then your answer would be 64.6416. And then you could find the slope between those 2 points. This gives us the average rate of change still. Okay, but at least it's, okay, these 2 points, okay, 2 and 2.01 for t values, are pretty close to each other. So that gives you an estimate of what the instantaneous rate of change could be. And then if you calculate this value, it comes out to be, okay, 64.16. Okay, so now if you take a look at page 60, table 2.1, you could choose smaller values for delta t. A delta t as in the difference between your second point. In my case, that was 2.01 and 2. My delta t would have been 0.01. But if you look at table 2.1 on page 60, if your delta t happens to be even smaller, 0.001 for example, your average rate of change for those 2 points, which could be an approximate value for the instantaneous rate of change, was 64.016. So it was slightly less than this value. If you make it even smaller, it's 0.00001, for example, for your h value, or the delta t value, your instantaneous rate of change, the average rate of change for those 2 points was 64.00016. Once again, that's an approximate value. That could be an approximation for your instantaneous rate of change. Page 60, example 2, also gives you a way to figure out, okay, a way to see what the instantaneous rate of change approaches to. Okay, I'll show you on my next clip.